Let's start talking about how text-based AI like ChatGPT works. So we'll start by talking about going from words to numbers. I think we can agree it's much easier to do math on numbers than it is on words. Large language models start with the step of turning words into numbers so it can do math on them. We want the numbers we give for words to be meaningful somehow, though. It's not enough to say or a, the word, very simple a, like that's word number 0, aardvark is 1, Aaron is 2, etc. Ziziva is 170,000 or whatever, because then the numbering has nothing to do with the meaning of the word. It's also not great for us to give the number 1 to the most common word and the number 2 to the second most common word, etc. It still doesn't have much to do with the meaning of the words. Let's consider another way of thinking. We can describe various colors of light by how much red, green, or blue they contain, each on a 0 to 1 scale. We might have a list like purple is 1 red, 0 green, 1 blue. White is 1 red, 1 green, and 1 blue. Black is 0 red, 0 green, and 0 blue. Blue-green might be 0 red, 1 green, and 1 blue. Then we can mix colors by kind of averaging them or doing a weighted average, like dark gray might be 20% white, 80% black. Very light purple might be 70% white, 30% purple, etc. And then we can just average those numbers. We could try something similar with animals, for example, and I'm just going to make up some numbers here. I'm not trying to cause trouble among animal lovers, which should be all of us. So let's say we put numbers to something like the word dog has 4 legs, usually. It's zero point 0.8 helpful, zero point 0.6 troublesome if left alone, 1.0 mammal, 0 aquatic. I guess some dogs are slightly aquatic. Fish has 0 legs. It's zero point 0.1 helpful, zero point 0.1 trouble if left alone, 0 mammals, 1%, 1.0 aquatic. Chicken has 2 legs, is zero point 0.3 helpful because they make eggs sometimes. Zero point 0.3 trouble if left alone, 0% mammal, 0% aquatic. Then we could represent the word dog with a list of numbers like 4, 0.8, 0.6, 1.0, 0.0. And in math, we call a list of numbers like that a vector. Here we're only using 5 numbers to characterize each word, but in actual large language models, they can use thousands of numbers in a vector for each word. It gets more difficult with some words, especially homographs like bass. Like a person could be a bass singer or a tuba plays bass notes. So we could say that's a 1.0 for singing or playing low notes. It also is a 0% fish, and it's kind of the opposite of treble. So maybe it's a -1 treble. Bass, which rhymes with pass, is 0% about singing low notes and is all about the particular kind of fish and has nothing to do with treble. So maybe overall the 4 letters BASS gets listed in some table of initial values as like 0.83 low notes, 0.17 fish, -0.83 treble. If the low notes version of BASS is that much more common in the training data than the fish version. The LLM doesn't look at the context of a sentence or a paragraph to begin with when it's trying to figure out which version of a word it's seeing. Later in its processing, it adjusts the numbers based on the context of surrounding words. The powerful but counterintuitive thing is that we don't have humans sit down and write out categories like number of legs to characterize a word like I showed above. Instead, during the large language model training, we have the computer adjust the numbers until it can give good predictions of the upcoming words based on the words it's seen so far, without actually trying to put descriptions to each category that we're putting numbers to. Later, we'll talk about how LLMs use pieces of words called tokens rather than whole words.